On behalf of Phoenix Integration, welcome, and thank you for joining us for today's webinar presentation entitled Functional Verification of Complex Engineering Designs Using System-Level Modeling. Today's webinar will be presented by Mr. Paul Goossens, MapleSoft, and Mr. Andy Coe, Phoenix Integration. Paul Goossens is the Vice President of Engineering Solutions at MapleSoft, a mechanical engineer with over 20 years of experience in both engineering and software business management. His previous positions include senior management positions for companies in engineering modeling solutions and high-performance real-time simulations. Paul has built a strong reputation as an expert in real-time applications, particularly in high-fidelity simulation of mechatronic systems for hardware-in-the-loop applications, spending a good part of his career promoting model-based methodologies. And from Phoenix Integration, Dr. Andy Coe currently serves as the Engineering Service Manager. His duties include managing the production team, working on commercial and government projects, research project management, application engineering, proposal writing, and sales support. He interfaces with many of Phoenix Integration's customers, including JPL, Lockheed Martin, U.S. Army RDEC, Honda R&D, and DARPA. Additionally, Andy serves as a technical resource on all things systems engineering at Phoenix Integration. Before joining Phoenix Integration, Andy was the Director of Engineering Services at Avid LLC. At Avid LLC, he has served as Project Manager and Technical Lead for aircraft design and analysis projects. Dr. Coe has also served as an adjunct faculty member at Virginia Tech, teaching both senior aircraft design courses as well as basic aerospace engineering material. He has also taught short courses to industry on UAV design. He is an active AIAA member, serving in leadership roles on the Multi-Disciplinary Design and Optimization Technical Committee. Today's webinar will run approximately 45 minutes long. Following the presentation, we will open the floor to questions. To ask your question, please use the Q&A feature in your WebEx window. We recommend that you view the webinar in full screen. To do so, please click the down arrow in the upper right-hand corner of your screen and scroll to Fit to Viewer. We are also recording this presentation today, and you will be notified via email once the video is available for download from Phoenix Integration site. And now I will take a few minutes to introduce Model Center. Now, I'm sure many of you have been to see a symphony orchestra at one time or another, and if you have, you may have wondered why the conductor gets so much attention. When the conductor enters, there's a lot of applause, and everyone really focuses on the conductor. And it's certainly not because the conductor is going to play any musical instrument, and the conductor isn't there to teach the people in the orchestra how to play either. These people have spent their lives becoming experts on their instruments. But I think we all understand the conductor is important because the conductor is coordinating the activities of all these people. A good conductor can make all the difference. The conductor not only chooses what is going to be played, but makes sure everyone plays it with the same interpretation, that everyone is listening to one another and is coordinated with one another. If it's done right, the end result is a lot more than what you would expect, even with all these expert musicians on the stage. So, what if you had a conductor for you and your engineering organization? Someone who could coordinate all the different software tools that your team uses, and someone who can help keep track of all the data and help everyone collaborate and stay in sync. So, that is exactly what Model Center does. Model Center is not an analysis tool, so it doesn't do thermal analysis or structural analysis. Model Center is a framework to help you get the most out of your engineering activities. And if we look at the components of Model Center, there are three main pieces. The first piece is Model Center Integrate. Model Center Integrate drives productivity because that's the piece that will allow you to take any software that you or your team are using, automate the individual software tools, but more importantly, tie them all together across the network into an automated workflow, so you can run your analysis automatically in one sweep instead of having to do everything manually. So that's Model Center Integrate. Now, once you're able to tie your software together into these automated workflows, then Model Center Explore comes in, and that helps you drive innovation. Because what Explore does is it lets you run that simulation over and over again with different inputs, and really unleashes creativity because it allows the engineers to go in and focus on being engineers instead of writing scripts and worrying about mundane details like that. There are algorithms that help you search the design space, and algorithms that help you view and ask what-if questions about the design space. And the third piece is MBSE Pack, which allows you to connect your integrated workflows to your MBSE systems model. This allows you to evaluate the system requirements throughout the system design cycle using real engineering models. This unlocks the promise of MBSE. So those are the main aspects of Model Center. And looking at this next slide, you can see an example of a lot of the organizations that are using either one or all of those different aspects of Model Center. And now, today, it is my pleasure to introduce our first speaker. Our first speaker is Paul Goossens with MapleSoft. Paul?
Thank you very much, Carl. Let me just share my screen. Okay, you should be seeing my screen?
All right, looks good.
That's great, okay.
Yep, everything looks great.
Well, yeah, thanks a lot, everybody, for attending this session. I just, first of all, just want to say that I'm happy once again to be sharing the virtual podium with Dr. Coe. I'm sure we're going to have an interesting session over the next hour. I would also like to acknowledge the contribution to this presentation that's been made by my colleagues, Isasha Miyashita and Jyoti Banerjee, who will be on hand for the Q&A panel in case there are any detailed questions there. This session is something of a follow-on of previous presentations we have done with Phoenix integration over the last year or so. But to just kind of recap in terms of what has got us to this point and the reasons why our customers are coming to us to use these tools, it's largely around being able to facilitate the whole systems design development process right the way through from concept through to production. And where we pay particular attention is right at the early stages of that process, because if you can detect those design issues very early in that process, that saves a huge world of hurt later on, especially when you start building prototypes, and then it's only at that point you start getting all sorts of integration problems, and that gets very expensive and time-consuming to address. So there's a lot of attention being paid in this area, and this is where we are specifically active in terms of being able to facilitate the process or the connection between the architectural models that are being defined by the systems engineers. They're typically using MBSE tools like Rhapsody or Magic Draw, to be able then integrate the requirements from that into the design process. And typically, we will our tools are very much at the beginning stages in terms of being able to build a functional mock-up, that's specifically MapleSim, to be able to create a system-level virtual prototype, a dynamic model that integrates different engineering domains, into a single representation that can then be tested very early on to ensure that it's the design or the proposed design is going to comply with the requirements that are defined by the systems engineers. And obviously, there's a real challenge there in terms of being able to facilitate that flow, and that's where we can see a lot of value in working with Phoenix in terms of bringing all this together. So, as we start to build that functional mock-up, we'll start with relatively simple representation of the system that gets increasingly detailed as you go through the design process. And you need something that's going to be able to integrate what typically turns out to be a highly iterative process. But it's never as simple as just going from one step to another. So you need a tool that's going to be able to bring all that together, and that's where we see the real value, and certainly our customers see the value in being able to bring all this together within the Model Center environment. And of course, we'll see a bit more detail what that actually means. So just to recap on what MapleSim actually is and how we feel it fits very well into those early stage compliance tests, is that it's a multi-domain system. So you can take design aspects from various different domains, whether it's mechanical or electrical or software or thermal, electrochemical, whatever you name it, whatever the subsystem, the engineering domain of that subsystem happens to be, it can be represented as a dynamic model within the MapleSim environment. And our sort of a causal representation of those systems makes the process of connecting those different domains together very simple. It also happens that we're using the same kind of hierarchical structure or subsystem structure that is typically manifested within systems engineering diagrams in order to be able to, so we can make a pretty much a direct mapping between the goals or the requirements of the system design and the actual subsystems themselves. And this could be whatever level of granularity is required. So this can go from at the component level to the subsystem level to systems of systems right over to the complete the complete product. So one of the things we want to dwell on a little more detail in this session is really the challenge that we're starting to see within many of our customers in terms of trying to bring the activities of the systems engineer with the analytical engineer, or the systems design with the actual analysis in order to support the requirements or the specifications for that product. So at the moment, we have organizations that have experts that are driving tools like Magic Draw and Rhapsody that are building the system architecture, the product definition in terms of structure, behavior, requirements, and constraints. And then we have engineering analysts using tools like Maple and MapleSim in order to do things like requirements compliance tests or trade studies and so forth, and immediately see what effect those changes have. However, what we're seeing within our organizations, there's a whole wide range of design stakeholders that are not necessarily systems experts, but actually need to be able to feed into the product definition process, and these people are typically not experts in using tools like the traditional tools for doing this kind of thing, and really need some kind of much easier tool for doing that. And that's where MapleMBSE comes in. So this is a product we announced last year that allows many different stakeholders to be able to bring all the different requirements that are driven by different activities that feed into the system or the product definition through using a commonly used spreadsheet interface, and that spreadsheet interface is ubiquitous. Everything is driven on Excel. So if we talk a little bit more detail about MapleMBSE, it's an intuitive spreadsheet-based user interface, and we'll talk through this in the demonstration, how this works in terms of defining the system definition. It's fully integrated with standard MBSE platforms such as Rhapsody and Magic Draw. So any SysML models that have been developed in these tools can be directly impacted, or can be directly developed using MapleMBSE. And of course, we can do things like impact analysis straight away in terms of if we make a change to a requirement, or we find that there is a requirement that conflicts with other things. Those things are very easy flagged. It also provides different views for impact analysis of the requirements, failure mode and effects analysis, trade-off studies, and the structure analysis of the model. So it's really the model structure. So there are well-defined tools for doing that, such as the design structure matrix that can be that is implemented within the spreadsheet interface. So with that, I'd like to pass over to Andy to talk about how this can be implemented within the model center environment, and then we'll talk about with a demo after that.
Okay, thank you, Paul. Let me share my screen. Actually, Carl, would you hand me the ball for the presentation, please? Thank you.
Yep, it should be in the process of switching over right now.
All right. So, do you see my slides right now?
Yes. Yes.
Okay. So thank you,
Paul.
Yes,
everything looks great.
Excellent. Thank you, Paul. So I'd like just to start by talking about bridges. So we all use bridges on a day-to-day basis, even and when they don't work, we're really at a loss. A lot of bridges are known, such as this one. So this is the Hennepin Avenue Bridge in Minneapolis. If you are familiar with bridges, this is probably not one that you would know. It's not a famous one. There are famous bridges. This one we all recognize. We know this is the Golden Gate Bridge in San Francisco. Well, bridges connect two different locations, usually separated by a barrier or a gap, such as a river or a gorge. Without it, it would be difficult to get from one side to the other. We rely on them so much that we take them for granted today. However, if you think about it, bridges foster communication, transport, movement of goods from one side to the other. It ultimately improves the economy and the well-being of the people on both sides of the bridge. It is, in a sense, an enabler to do things what we could not do before without it. So let me talk to you and bring that analogy to what we saw a number of years ago. So a number of years ago, we at Phoenix Integration noticed a gap in engineering. On one side, on the right side, we have discipline engineering models. So this we know very well. We at Phoenix Integration have been doing this for over 20 years. And that is to help integrate and automate the analysis. You can take engineering analysis such as MapleSim, CAD models, satellite models, and put them together and have them run and communicate with each other in a workflow. Now, on the other side, we have systems engineering. And over the last 10 to 15 years, systems engineering has been moving from a document-based methodology to what we call a model-based methodology, what we call MBSE that Paul explained just now. Now, this is a great way to control and to manage complexity as a model is consistent and is traceable. However, what we noticed was the systems model was basically just descriptive. Now, that's on one side. So the gap is, what if we could bridge between the systems model, which is descriptive, and the domain of discipline engineering, which is executable? And so we created a product called MBSE Pack. And what MBSE Pack does is exactly a bridge. It connects the systems model with the engineering model such that data can move from the systems model through MBSE Pack to the engineering model. We can do the analysis and then bring it back. Now, what that does is that we can check requirements. We can calculate system performance. We can perform off-design trade-offs. So our product, MBSE Pack, basically uses the SysML parametric diagram. So the SysML is the language that is used to describe the systems engineering. So we use SysML parametric diagrams to evaluate designs. With that, we can do compliance analysis, requirements compliance analysis, where the information from the engineering models help inform that compliance or that verification of those requirements. We can do trade-off studies, and the results from the engineering model can be updated in the systems model. So this product we have found to be very powerful. We have found that it completes or it unlocks the promise of MBSE. just an example of one of our clients that actually used this very effectively is from Northrop Grumman. So this slide was presented by Northrop Grumman at our last users conference, and it's basically how they have integrated our tools and MBSE PAC Model Center into their process to win proposals and to deliver on the products that they make. So it starts off with requirements, where they then create system descriptive models for the system that they're looking at. Using Model Center, they bring in the analysis, either in-house or any of the tools, and put them into workflows such they can perform analysis and calculate the performance that they need. These analytical models are then used to perform trait studies. And these trait studies inform them and help them make decisions. That's updated through MBSE PAC to update the descriptive models back again so that they can look at the whole system, they can look at the system as a whole and also check with their requirements. Now, based on what they see here, they can either update their requirements or update their design, and then that cycle goes on until they come to a final design or a design that they can move forward. And this is a seamless process that they've integrated into their everyday work or their design cycle. So that is just basically in a nutshell what MBSE PAC does. Now, how does that fit into what we're presenting today? So let me just give you an example scenario of how MapleMBSE, MapleSim, Maple, Model Center, and MBSE PAC, so all those tools, how they can work together in an ecosystem. So we start off with the systems model. So this could be housed in tools such as Magic Draw or Rhapsody. In the systems engineering world, we call this model to be what we call a single source of truth. So all the information is kept in the systems model. It describes the complexity, it describes every piece. Now, what Paul explained just now, they have MapleMBSE, which is an easier way to connect to the systems model. And you could have a stakeholder that is just working through MapleMBSE, which is easy to use because it's Excel-based and it's a spreadsheet-based, and they're exchanging data between the systems model. Now, on the other side, you have Maple and MapleSim, which are analysis codes. So discipline engineers, perhaps systems engineers, use them to do analysis. Now, that connection is made through MBSE PAC. So MBSE PAC would then be able to connect the data from Maple and MapleSim and send them into the systems model. So now you have an ecosystem where stakeholders have an easy tool to use to exchange data between the systems model. And when the systems model is updated, systems engineers can then look at the updated requirements, updated designs, updated information, send that information to their analytical model through MBSE PAC, and return the results back to the systems model such that it can be updated and also then be represented back in MapleMBSE. So it is a way to kind of bring the team together and to share information in a much more automated way. So we will be presenting to you such an example in a form of a video. But before I do that, I would like to kind of just set the stage for what the analytical model is that we're going to show in the video that's coming up. And some of you might have seen this in previous webinars. We created a multi-domain system level dynamics for an electric car that looks at things like the lithium-ion battery, the DC motors, the vehicle dynamics, and puts all of that is modeled in Maple and MapleSim. So what we have done is we have wrapped that into Model Center, and it's connected to the systems model. And so we will be showing to you a video of how the MapleMBSE can connect to the systems model which is then connected to this analysis model in a seamless way. So I'm going to switch over to Paul because he has the video, and I'll let him, and we'll talk through it together. So Paul, I'm going to stop sharing and let you show your screen so that we can run that video.
Sure. Yep. So yeah. So let me. So I think just a little bit of detail here, just so people can see in their minds what's going on when we go through this the demonstration. So what you're going to see is the integration of that model that Andy has just described, where we're executing simulation over and over again, depending on different drive cycles and loading conditions. And one of the key the design elements in this, which we will focus on for the purpose of this demonstration, is the overall range of the vehicle. And of course, there are many different factors that can that can drive that. Since this is a batteried vehicle, there's going to be a very finite energy source. So the range anxieties are obviously one key driver for any kind of design specifications for this. We're actually going to be using Nomagic's Teamwork Cloud Server to implement the system model, which was initially developed in Magic Draw and is now implemented within the Cameo systems model environment. So this is the stuff that the systems engineers would have set up to help define that. We are then using MapleMBSE as the tool that other stakeholders, engineers, design engineers, could be using to define the more detailed requirements and certainly make changes in those requirements, and then be able to then drive the model, as Andrew described, through MBSE Pack to run it through various compliance tests or requirements compliance tests over various driving scenarios. So let me run the video. So what we're seeing here is MapleMBSE running up within the Excel environment. It's grabbed all the requirements from that system model, and then you have the spreadsheet interface that allows you to define those requirements. This is the same model represented within the Magic Draw environment, and you can see the same those upper and lower bounds are made available inside of that. So now we can take a look at the block tree structure. So this is taking the BDD, the block diagram definition, and representing it in both environments. Here we can make the connections in terms of satisfaction criteria that again are then reflected back into the system model. So now let's take a look at let's say 100 kilometers is not going to be very satisfactory. So let's change the upper bound for the range to 200 kilometers. Now we can save this back into the Teamwork Cloud server. And now that change has been committed, and we can now go back into Cameo here and update the model, and we'll then see that change reflected within this block, the block we see in here for the drive range. Now we'll flick over to MBSE Analyzer. Andy, if you want to talk through this part.
So what we're doing here is we opened up MBSE Pack, which is MBSE Analyzer, and we're going down to the parametric diagrams that's connected to the Maple and MapleSim models. And all we do is we run it, and using the information from the systems model, it will run the models behind the scenes and update the analysis and the performance of the vehicle. So you can see here the range meets the requirement, but not the weight. So from there, we can take, say, this particular design and save it back into the model, either back to the default values or as an instance. In this case, we're saving it as an instance or as a design case. We can then upload that information back into Teamwork Server, into that so that it can be shared to the rest of the team. And if we look here over in MapleMBSE, that information is then updated back in MapleMBSE.
Yeah.
Okay, so we can see the weight has changed.
And if we now decide that there's been a change to the design that requires the body weight changes, then we need to see what kind of impact that's going to have on the design by sending that back into the back into the system model.
Right. So that goes back into Teamwork Server. We update our model on the systems engineering side. That should be reflected then in the model that the systems engineer would look at. Open up MBSE Analyzer again, and we can rerun the analysis to see what that effect is if there was with that change. MapleSim, and we can see now both requirements have been satisfied based on that design change.
And we're ready to rock and roll, as they say. Okay, that's pretty much wraps up the presentation and so the demonstration of the integration with all the pieces working together. Okay, well, thanks for helping me with that, Andy.
Okay.
So just to wrap up, obviously over the years we've seen MBSE being increasingly implemented and considered certainly a proven business methodology for managing design complexity, risk, and costs. We feel that MapleMBSE is certainly a very powerful addition to the whole MBSE process by allowing a much wider range of stakeholders to be able to directly feed into the product definition while maintaining the integration with the SysML architectural model. And everybody can basically observe those changes and still maintain that single source of truth within the design. MapleSim, as always, provides a rapid functional capability for building rapid functional mockups. So virtual prototypes, if you like, that can be used to help for the verification of complex multi-domain dynamic systems. And Model Center brings everything together for doing those requirements compliance testings through the sort of V&V process all the way through the design process to ensure that any changes that are made in the design, the impact can be readily understood, and any changes that are required to address that can be made. And fundamentally helps to bring all these tools together to realize the V process in a much more integrated way. So with that, if I can just do my Steve Jobs thing and say one more thing. If you'd like to find out more about how MapleSim and our tools, MapleMBSE, integrate with Model Center, you can go to our website to find out more. Last year we made available a free plugin for Maple just to help the process of integrating MapleSim and Maple analyses into the Model Center environment. So with that, I'd like to thank you all for your time and attention, and we're ready for some questions.
All right. Well, thank you very much, Paul. Thank you very much, Andy. We greatly appreciate that excellent presentation. At this point, we will move into the Q&A portion of the webinar today. As a reminder, please use the Q&A feature in your WebEx window and not the chat feature to ask your questions. When using the Q&A feature in the WebEx window, please be sure to send your question to all panelists so that everybody here is able to see your question. Once you submit your question, you will not be able to see it, but please rest assured that we will try to address as many questions as possible today. If for any reason we are unable to get to your question today, or there's more detail that we need to provide, or if you have additional questions after the presentation, we're more than happy to continue the conversation. If we don't get to your question today, we will have your contact information captured and we'll reach out to you with follow-up. And certainly if you have any other questions we don't address today, just let us know and we'll be more than happy to help out. In terms of the questions coming in already, we did have a few questions come in already asking if the presentation today is going to be made available. And yes, we will have this presentation available on the website for viewing later. And once that is available for everybody, we will go ahead and post that on the website and also send you an email with that information. So jumping into the questions that are coming in, we already have a few good ones coming in. First question here, you showed quite a few tool sets and MBSE as the bridge. How wide is the connectivity variability of tool sets between the bridge?
So I can answer that. So the way we, so currently MBSE pack connects to two systems modeling tools, basically Rhapsody and Magic Draw. And the bridge connects to Model Center, and Model Center is designed to be tool agnostic. So we can, I would say, a majority of the tools, probably 90 to 95% of engineering tools, can be integrated within Model Center, and we've done this for 20 years. So it could be an in-house code, it could be MATLAB, it could be Excel, it could be CAD tools, FEA, CFD, you name it. And it's been used widely for a number of years by many companies around the world. Now, since MBSE pack connects to Model Center, all the tool agnostic nature of Model Center, whatever can be wrapped in Model Center, then can be connected through MBSE pack through the systems model. So in that sense, there is a wide range of tools that can be made available to the systems model through MBSE pack to do the analysis that we talked about.
And if I could just reinforce the integration of the simulation tools, when we first got together to work on this, there was no dedicated interface for Maple for doing this. It was just simply using the scripting capability. Very quick, very rapid. Yes, a little bit of effort to do that, and that's the reason why we came up with the plugin. But it's very readily achievable.
Excellent, thank you. Next question, were the parametric diagrams that were created specifically used for integrating the MBSE tool and analytical tool, or were there other purposes behind it?
I guess the answer would be yes. So the parametric diagram, so for this example, we did create the parametric diagram specifically to integrate the MBSE tool or the analytical tool. However, the parametric diagram is also used to kind of describe how the analysis is being done and what different constraint blocks or what different constraints are connected to different value properties. The nice thing about the parametric diagram is that this is specifically this pattern. It was created for this specific pattern. So you could connect different analysis through MBSE pack to constraint blocks, and then create and reuse those constraint blocks in different parametric diagrams, and it would automatically create the models that is required and automatically generate them through the parametric diagram. So if you say had an older model that had not been connected to analysis and you had already described a parametric diagram, all you would have to do is for each constraint block, you would associate that with a particular model center analysis or model center model, and through MBSE pack, it would automatically generate that composite model based on your parametric that you created. So the answer to that, to the original question is, I think yes, both.
Okay. I do see some questions coming in here. One question asking about licensing, and we will follow up with you directly to answer your license-specific questions there. So for that user, we'll just reach out to you directly to discuss the different licenses available. Another user asked about seeing the questions in the Q&A panel here. Just a reminder, you will not see the questions once they've been submitted, but we are receiving your questions on this end. Next question coming in. The example presented was fairly hardware related, yet a number of domains were described at the beginning of the webinar. How might I use MBSE Pack to work on a socio-technical system such as supply chain or network where supplier models are built, and then use those supplier models to show design requirements, visibility, and then analysis of the design, including things like speed and time to market and whatnot?
So I don't think that there's any barrier to that, as long as you can describe your system through SysML in a systems model. And so the tools are very generic. So it's not limited to mechanical or specifically engineering design, although that's our primary market. But you can integrate just about any tool. So if your socioeconomic model has some analysis that you'd like to bring in to kind of look at it from a systems level, it should not be an issue to kind of bring that into Model Center and just connect that again through MBSE Pack. So the tool isn't designed for a particular market or segment of engineering per se, but it's meant to be very generic. So we've seen integrations from architecture to electronic design through engineering. I think at one point even we had a client in the banking industry. So I don't think it would be an issue. And just
Excellent, thank you. Go ahead.
A little plug there also. If you have a model that you're not sure of, we'd be happy to kind of consult and talk to you about it to see how our tools can help you in that arena. Sorry, Carl, go ahead.
Excellent. Thank you, Andy. Another operational question from a user asking about the questions and answers, and if those this portion of the webinar will be made available after the webinar. And yes, we are also recording the Q&A portion, so you will be able to hear the questions and answers after the fact as well. Next question coming in: how exactly does MapleSim integrate with the MBSE tools, say MagicDraw? Does MapleSim leverage the MagicDraw API, for example?
Certainly MapleSim itself is essentially it's an analysis tool. I mean, so what our users will typically do would be to create a system model based on specifications that come from the SysML side. As yet, there's no real magic bullets. A lot of work being done in this area on how, say, for example, maybe a first-pass system representation could be generated from the SysM models, but I don't think anybody has any ready answers on that. So it is very much a manual process. Really, the thrust of this particular presentation is more about how we integrate with the requirements that come from the design side. So in terms of that integration, it's very much about running a virtual test and then doing the kinds of analysis that we've seen in MBSE Pack to determine if the output of that model is going to comply with those results. All I can say is that this is kind of where there's a lot of development going on, and certainly in the future where we can perhaps see a better or a tighter integration between the two worlds. But I just don't think we're quite there yet.
Excellent, thank you. Question coming in asking about capturing and exchanging information generated, asking if the tools demonstrated today can be linked into a database or a backend such as Oracle or SQL for the purpose of exchanging information.
I think that's probably one for you, Andy.
Okay, so from the analytical side, we do link. We can link to databases to kind of bring in information. That's usually done on a case-by-case basis, in the sense that it's application specific. So exactly what do you want to get out of your Oracle SQL environment, and exchange information in the analysis itself. Now, with respect to exchanging information from that database into, say, the systems model, we do not have a connection to it. Although I might venture to say that maybe the systems modeling tools does it. Paul, does MapleMBSE look at any of those databases and bring any information in through MapleMBSE?
I'm going to bring on my colleague to answer that question. Hisashi?
Yes. MapleMBSE itself has actually the adapter capability to connect with the other tools, and it's based on Eclipse modeling framework, and the EMF can access to the many databases by using CDO, for example. So the actually is technically yes, and then the actually is officially supporting is actually the we need to work on the understand the actually is requirements for this kind of use cases. So actually is it will be we understand that's very important to integrate various kind of the databases with systems models, and it's also via future work for the actually is practically supporting that.
Thank you.
Thank you. Next question. Your focus in this presentation has been on MBSE software tools. What recommendations would you make regarding design process changes that have been found in your experience to be useful or necessary to properly leverage MBSE using such tools?
Wow, that's a big question.
I was going to say, we could take the whole hour to talk about that one.
Yeah, it's. I think I think if you ask anybody who's active in this area, they'll have many different opinions. I'm probably going to sort of step aside or step around the particular question and say that this is probably the perennial challenge in terms of implementing these kinds of methodologies. The tools just make the process easier. But there are many other aspects, in terms of just corporate inertia, process, cultural changes. Basically, we're dealing with people, and there's a lot of work that has to be done on that. And I think as we start to see a body of case studies that are coming out of this activity, that will actually help in doing that. If anybody is interested in getting a deeper dive into this kind of thing, I would certainly recommend participating with the INCOSE group. There are many sort of best practices, training sessions, discussion groups that sort of involve themselves very much in this particular area.
Yeah, and I would agree with Paul on this one too. I think usually the common thing that we've seen for an organization that is moving in the MBSE world is the culture, changing culture, people, and also the inertia, the corporate inertia. What I've seen that usually works is the advice to start small. So don't try to bite off too big a chunk of work right at the start. Start with a small project, a small use case, and build on that so that you show value and you show a return on investment for the cost, because moving to MBSE has much higher initial cost, but it pays off in the long run. So I would say if there was one thing that I would recommend, start small.
I agree.
Excellent. Thank you, everybody. Next question, is there a two-way connection between requirements in the systems model and the simulation execution via Model Center? Specifically, if requirements are updated in the SysML model, do they pass through to Model Center to MapleSoft, or is the data flow only one way?
The data flow is two ways. So if you have but that's controlled by the user using MBSE pack. So you as the systems modeler would bring down and be able to analyze. So once the requirements is updated in a systems model, you can run the analysis, and you can then decide whether you want to return that data back. Now, the requirements per se, so say, for example, if someone changes the requirements for the battery capacity, that would be done in the systems model. Or if you have an external tool such as doors, you would do that, and you would do a sync to the systems model first, and then we can do the execution via MBSE pack through Model Center. So the flow of data is both ways, but you as the user controls when that happens.
Excellent. Thank you, Andy. Do the engineering analysis models need to be parameterized to be used in Model Center, or are they just used to generate a database?
It would be the former. So the engineering models need to be parameterized so that we can try different designs. It is not a database based system.
Yeah, in this particular, certainly with the MapleSim tools, all the models that we develop are fully parameterized.
Excellent, thank you. Users asking here, is this essentially an optimization tool in the end, tying variables across the models?
That would be a matter of perspective. I think it is more than just optimization. Optimization is just one way you can look at it, and you can apply to this. Usually, when we talk about optimization in an engineering sense, is an automated way of searching for a design and getting a better design in the end. This could use those tools, but it is more than that. What I see this to be is a connection of information and and ensuring consistency of information. So whereas in the past, when the systems model is separate or set aside or not connected to an engineering model, the systems engineer would have to either email some information or print it out on a piece of paper and walk it over to the domain or discipline engineer and have that be run. Now with this automated process, the flow of information and the consistency of information is ensured and can be used. Then when you talk about let's look at it in an optimization sense, then you can apply that. So I see optimization as a design tool that is included in this entire process that this opens up. So you could look at it that way, but I think it's a lot more than that.
Yeah, I mean, fundamentally, yes. What everybody's trying to achieve here is an optimal design. It's the best possible result given the resources that are available too. But that involves a lot of human interaction and group collaboration to do that. There are probably sort of smaller elements, and certainly we get involved in doing sort of optimizations at a much smaller level. But at the end of the day, it's a process rather than a tool that's actually delivering the optimal results.
Excellent, thank you. How does doing the verification in the model, which is an abstraction of the product, help when doing actual end product verification, particularly with the regulatory agencies?
Yeah, that is actually a very good question. I mean, what we're showing here is very much a snapshot at the early stages of the process. But I can certainly imagine scenarios where, as the development, as the design evolves through to say the first prototype, there are many aspects that need to feed into that, and that includes legislative, economic, and of course safety aspects that will be typically will be captured within the system architecture, and that's when we talk about many different stakeholders that need to feed into that. That's exactly one of the stakeholders I could imagine would have to feed in that. What are the safety concerns in this? What are the cost concerns and so forth? And those will all be factored in. So I can see as the design process plays out, all those factors need to be integrated into the virtual mock-up, if you like, beyond just the dynamics.
And in a sense, bringing the regulatory aspects and requirements into the design in that V process is important. And so this is partly a process question of when and how do you bring those requirements early on in the design, such that now you can go down and use that V process, but early on you can use the simulation tools like MapleSim and Maple, and as you go down you increase in fidelity, but bringing those requirements as you go down in the V process until you create a prototype, and even further from that until when you manufacture. That's all being taken care of and being looked at as part of the requirements process. So that would be part of the MBSE process, or the systems engineering process, that's applied to the product.
Excellent, thank you. Do you need Phoenix as a server product if you have MapleSoft or MapleMBSE?
I would say you don't need it, but it would make it very much easier if you did have that capability.
Okay, thank you. How deep is the integration with Cameo Team Server, and is there a similar integration with Rhapsody Design Manager and its CLM environment?
Yeah, I'll answer to this question. It's actually we are using the EMF API provided by Cameo Teamwork Cloud. We are supporting the team. We don't support Team Server. Teamwork Cloud. It's actually the newer version of the server environment by NoMagic. And Rhapsody Design Manager and CLM is actually a server-based integration. So it's a different type of the architecture, but the intention is the same. And it's using OSLC-based interfaces to integrate that. And technically, also we had a prototype to connect to these servers as well. And in the type of the broad perspective, the answer is yes. And we can use different types of the APIs to integrate various tools in MapleMBSE. Yeah.
Excellent. Thank you very much. Go ahead, Paul.
I'm good. Thanks.
Did you have other comments to add, Paul? Or okay, excellent.
No. I think that covers everything.
All right. Okay, thank you very much. And we're getting to the end of the hour here. I think we're going to go ahead and wrap things up. If you have asked a question that we were not able to get to, we will follow up with you directly. And if you have any additional questions, certainly feel free to reach out to us, and we would be more than happy to continue the conversation. I'd like to give a big thank you to Paul Goossens of MapleSoft and Andy Ko of Phoenix Integration for the excellent presentation today. And we hope that you will join us for our next webinar presentation in February, Applications for 3 Research Use Cases in Model-Centric Engineering using Model Center and MBSE Analyzer. We also have some workshops coming up here in February and March in Boston, Massachusetts, and in Germany. And finally, I'd like to remind everybody about the 2018 International Users Conference. This year will be taking place in Annapolis, Maryland, April 17th through the 19th. You can find more information on these events and on the upcoming workshops and webinars on the Phoenix Integration website, and you can find more information on the MapleSoft products on the MapleSoft website. Again, if you have any other follow-up questions, we'd certainly look forward to continuing that conversation with you, and we thank you very much for joining the webinar today. Thanks again, Paul and Andy, for the wonderful presentation and Q&A, and thanks everybody for joining us. Have a great rest of your day, and take care.